Einstein published his general theory of relativity, which changed, changes, and will change the way we perceive time. In this groundbreaking theory, he proposed that the laws of physics are the same for all non-accelerating observers. This basically explains why, if you were to watch a car drive past you, you would interpret the car's passengers as moving at the same speed as the car, since their speed is relative to your position as an observer on still ground. Meanwhile, inside the car, the passengers feel like stationary objects, since their motion matches the car's motion relative to the outside world. But while Einstein's theory of relative motion could be applied to all objects in the universe, he also realized that one exception to relativity was light. Light always moves at a constant speed. These two principles led Einstein to conceive of a link between time and space, also known as space-time. And one of its tricky implications is that the perception of how time passes can be different between two observers depending on how much faster one is moving compared to the other. So, if it's possible for two observers to have two accurate perspectives of time's passing, but for those perspectives to be different, whose clock is right and whose is wrong? Oddly enough, they're both right. After all, the fact that different time zones exist are enough proof that your watch and someone's watch across the world will read different times every second of the day. We're inclined to think of the passing of time as objective or universal, since humans have all more or less agreed on the same system to organize our busy lives and to be on the same page with our neighbors, either next door or a few countries over. But while time is a convenient tool for keeping track of the past, present, and future, the true nature of time is trickier to grasp once you realize that the past, present, and future could all exist at once. When you look up at the sky, you might be able to point out Proxima Centauri. After the Sun, Proxima Centauri is the closest star to Earth, and it's only about 4 light years away. So the light you see now is actually 4 years old in our time. If Proxima Centauri exploded, we wouldn't know about it until 4 years later. That's because the speed of light is constant, no matter where you are in the universe. Another thing you need to know is, the faster you move, the slower time does. This explains how astronaut Scott Kelly spent a year in space and came back to Earth 13 milliseconds younger than his twin. Now, with these two examples, let's put an astronaut on a planet that's 4 light years away. That means his present is unfolding 4 years ahead of you. Anything you do now on Earth is already in his past. Put simply, the past, present, and future all exist at once. Now, before you have an existential crisis, there's a theory that might make living in the past, present, and future all at once a little easier. It's called moving spotlight theory, and it basically argues that there is only one absolute present, which changes moment by moment as if a spotlight is moving over it. So with that information, you can begin to see how the passage of time might be an illusion. There's no single objective past, objective present, or objective future. The illusion of time is crafted by our memories, and our experiences, and our upcoming plans, which help us organize our life into a neat sequence of events. But depending on where you are or how fast you're moving, that sequence will be very, very different. So whether you're new age or nostalgic, or if you just prefer the present moment, don't worry, there's a place for you somewhere in the universe. It might take you hundreds of years to get there, but if you move fast enough, you'll get there in no time.